Okay, good afternoon, everyone. My name is Mark Hirsch. Coming here from UC Santa Barbara, and I'm excited to share some new work we have that we're calling Sketch, a fast interactive 3D printing system that's based on liquid crystallization. So I want to briefly look at a few works from the field of interactive fabrication that deal with using, have some relationship to manual practices. So for example, using handheld tools to guide the laser cutting process or augmenting a sculpting tool, or to use direct sketching in contexts like embroidery or on-skin 3D printing. However, if we do think about additive 3D printing, most methods are very slow and they preclude real-time interaction for expressive or artistic creation. They don't allow for the same types of exploration that an artist might get from drawing or painting, for example. And that's the motivation behind Sketch. So Sketch is a system for interactive sketch-based 3D printing that's based in rapid crystallization of supersaturated solutions. And in this case, sodium acetate and water, which is cheap and safe and easily disposable. The near instantaneous solidification of the solution allows the robotic printer to be operated like a digitally augmented sketching interface. So you can see that in this video here, the user is putting input into the stylus on tablet and controlling the 3D printing process in real time based on these freestanding pillars. And in a second here, you'll see a overhang structure that connects it on an incline. And it's especially this last feature, the overhang, that I think points towards some exciting possibilities for complex geometries because these kind of structures are often difficult to achieve in many other additive 3D printing processes. So let's take a closer look at this structure. This is about 15 by 10 by 3 centimeters, and it was printed in 77 seconds. So as you saw in that previous video, it's real time and pretty quick. If you look closer at the system, the interface controls the real-time fabrication process enacted by the robotic arm using a drawing stylus. The software is intended to support manual input in combination with constraints or dynamic procedural behaviors. This allows the system to computationally augment input from the artist to facilitate the generative creation of new forms. And just as an example of something we've already implemented, we're able to control the feature height of the object by modulating the flow rate of deposition and the speed of the robotic arm based on the pressure of the stylus on the tablet. Finally, the computationally augmented input is then sent to the robotic arm as a series of 3D locations where the material will be deposited, and the near instantaneous solidification occurs at that location. So what's next? Sketch is very early in its development, and one thing we'd like to do is observe how artists use this in extended practice to help inform how we will then develop the system. So this will certainly inform how we choose to computationally augment the input. It might also open up some new contexts like live performance, maybe new structural possibilities that are unique to this system, how we might develop the material more based on artists' desires or needs, perhaps create a rapid prototyping environment that they can test new designs before moving to a more conventional approach. And just in general, we'd love to see how we can better map the inputs from sketching to the digital fabrication process in 3D. And so with that, I'd just like to thank my co-authors, Jennifer Jacobs and Jan Visell, as well as institutional support from UCSB, the Retouch Lab, Media Arts and Technology, my home department, and the Stanford Department of Computer Science. And we have a poster up in the other room, so feel free to drop by and chat if you'd like. Thank you.